Okay, now you've done linear regressions, and we're going to look at a couple other types of regressions. But just to review, remember, you're going to take this table of data, copy them into the calculator, and then open the statistics calculator. From that menu, you're going to choose linear linreg. Linreg, ax plus b, that's slope intercept form, slope A and B for the y-intercept. And then the calculator is going to tell you what the exact line is going to be like that connects these dots as best as possible. And just keep in mind, if they say round all coefficients to the nearest thousandth, when it gives you this answer, you better put in these numbers from thousandths would be 3 decimal places. So use all 3 of these decimal places. And actually, that last decimal place would go up to 7 because that number is more than 5 or more. This number would go to 3 decimal places too. Ooh, and I saw an 8 there. That's more than 5, so you better make that 14.499 as your, oh, and gives you the answer. Just what I told you. And the calculator doesn't show you the points that you were given in the table, but it does show you the line. Once you get your answer and you submit your answer and you get it right or wrong, Delta Math, like here, will show you that line, and it'll show you that it's, connects the dots pretty well, okay? But how well, that is called the correlation coefficient, and we're going to be looking at this number in a little bit. But first, let's look at 2 other types of regressions. This next type is called quadratic. So it's not a line, it's not going to be slope intercept form. These points, and I know you don't see, exactly where they are, but they're going to roughly form a parabola. And that's why it's telling you this time don't use the linear regression, don't use a line, use a quadratic regression. And you can still copy the values in, but the calc menu, you're going to want this quad regression, quadratic, because the form of the equation is going to be ax squared plus bx plus c. This is called a quadratic. You remember this because of the x. You remember this. This is what makes parabolas. That's the pattern of a quadratic equation. And then here are your A, B, and C. Earlier this year, we had very simple A's, B's, and C's. And we learned how to find the vertex. You learned that the C value is the y-intercept. We talked about axis of symmetry. But these are going to be not your just simple whole numbers. And again, they're saying round to the nearest thousandth. So just keep that in mind when you put that equation in. They want you to round coefficients. Thousandths means 3 decimal places. And here's what, like I said, it's going to come out like this. The exact equation you make, it'll be perfect, but the data they give you is going to be pretty close to touching that line. That's why this parabola, it's better than a line. A line wouldn't touch these data points nearly as well. And the third kind of regression is going to be called an exponential regression. Okay, but it's the same process. Your calculator menu, exponential regression. And the way this equation looks, something different we haven't seen all year. You're going to have an A, and then you'll have a base for B, which is the base of an exponent. And this x is going to be anywhere from 0 to a million or whatever. But the b, the base, is going to be what gets taken to this power of x. But basically, once you do the regression and calculate it, it'll tell you what the a should be, which is outside of the parentheses, and the b, which is the base of the exponent, is going to go inside the parentheses. Okay, so the x is really powering up the 0.9, not this. This multiplies to the 0.9 after this gets powered up. So you can see it kind of makes a curvy. It makes a curve. This is kind of saying a curve is going to be better than a line in terms of kind of connecting these dots. I know it's kind of a little hard to see. To my eyes, maybe a line would work better, but you never know. If they're saying use a regression equation, exponential regression equation, do it, okay? A lot of times when the data curves, you want the exponent, you want the equation to curve with it. For this next one, I want you to remember that the calculator will actually tell you about R. R is a number that tells you how good the line, or usually you kind of think about a line first before you think about the parabolas or the curve, which is exponents. But it'll tell you how good of a line you can draw through this, okay? And R is any number between -1 and 1. R is never going to be bigger than 1. It's never going to be smaller than -1, okay? And let me show you what the different R's are going to look like. These are the different types of R's that you'll see. This is 0, practically 0, because, you don't see any correlation. It's just a mess. But watch this. This is very perfect positive correlation. Look at that. This means if you give me an X, I will absolutely tell you the Y, and I will be very, very accurate about it. That's perfect. This is just a plain line. You give me the equation of that line, I give you the X. You give me the X, I'll tell you exactly what Y it is. And this is not perfect, but it's pretty strong. Okay, so this R value is not going to be quite 1 like it was here. Perfect. Perfect means the R is 1, and it's a positive slope, so it's going to be positive. Strong means it's about 1, it's almost 1, and it's positive. That's a pretty good correlation with all that data. But weak means this, you can kind of think that maybe a line is going to connect these decently well, but it's definitely kind of a positive correlation, but it's kind of weak. It's not, it's like halfway between 0 and 1. Here's some negative ones. This, the more you go out here, the lower the Y's of these points are, so that's kind of weak, negative. Notice it's a negative number, but it's still not as strong as this. That's strong, but negative. Negative 0.93, my gosh, that's almost -1. But watch this, this is perfect. It's a negative correlation because it's a negative slope. And I guarantee you tell me the X based on this data, I will tell you the Y. I know the equation of this line. If I get the Y-intercept and the slope, I'll just tell you exactly where everything is at. That's perfect, negative correlation. So again, the R value is between -1 and 1. The R is somewhere in between. When it's at 0, that's like no correlation. Close to 0, weak. Okay? But close to 1 or -1, strong. Okay? It's about how those XY points cluster together. So when you get to the next question, you're going to be asked which of these regressions, these lines, represents the strongest positive linear relationship, like a line between x and y, a bunch of points. It's positive. These are the data points. And it's positive, so the line that kind of goes through them would be going up. And it's pretty strong. Like these are pretty close to the line. They're not like weak where the x and y's are totally random. It says it's pretty strong. So you've got to pick which regression is positive. And then second, you have to pick which has the best R value. Well, positive means positive slope. And remember, for these, A is the slope. I know we used to talk about M, but A is the slope. So this is positive, so that's a choice. This is negative, so we don't want that. That's positive, and that's negative, so we don't want that. So it's between this one and this one. Now, which one has the better R value? Oh my gosh, this is close to 0. That sucks. This is better. So this is our winner. Yep. So this had strong positive linear relationship. This one, because this was positive, that was negative. This is positive, that's negative. And between these two, this one was definitely closest to positive 1, not bigger. I mean, it can't ever really be bigger than 1, to be honest. Let's look at another one. Which of the following regressions represents a strong? Okay, let's try a different one that says negative. Strongest negative. Negative. So first of all, we got to find the ones that have negative linear relationships. And so this has a negative slope. That has a negative slope. This one does. This one does not. So let's look at these three, and we're going to have negative R's. But the one that's closest to -1, that's oh, sorry, this is not negative, that's positive. My eyes are bad, so ignore that. It's between these two. Okay, this is negative 0.02. That's darn close to 0, but this is the one we want. Okay, so it's going to be, I'm pretty sure it's going to be regression 2. Okay.